question like this that comes up in the Nat 5 exam all centres around trig identities. Now, there are two key ones that you need to remember when it comes to the National 5 exam. One of them is sine squared plus cos squared x, and what that is equal to. And the other one is what tan x is equal to. Now, sine squared plus cos squared, that equals 1. You have to make sure you remember that. Now, this can be rearranged so that you can get something for sine squared equals or cos squared equals. Now for sine squared, shift the cos squared across and you get 1 minus cos squared x. And for cos squared x, you do the exact same thing, except it's the sine squared you move, so it's 1 minus sine squared x. Tan x, you have to remember that that's the equivalent of sine x over cos x. Neither of these appear in the formula list, so you need to remember these off the top of your head to be able to use them in a question like this. Now, if you ever get a question that involves trig like this and it involves the word simplify, what that means is it's going to be a case of using trig identities to make it look a little bit easier. Now, this one wants you to expand and simplify. So first thing you need to do is expand the brackets, then simplify what you've got using some form of trig identity. So if we expand the brackets, sin x plus cos x all squared, that ends up giving you sine squared x plus sin x cos x. I've then got plus cos x sin x after that. And then I get a plus cos squared x at the end. Now that we've expanded it, we have to simplify it. Now we have to think about any of these identities that come up. Now we've nothing that involves sin x over cos x or a tan x, so that one we don't need to think about in this scenario. But this one here, sine squared x plus cos squared x equals 1, well, we've got a sine squared and we've got a cos squared there. So if we group them, what we can say is that that's the equivalent of sine squared x plus cos squared x here. And then if we look at these two here, I've got a sin x cos x plus a cos x sin x. Well, they're the same thing. That's like saying 3 apples cost 30 pence, but 30 pence is the cost of 3 apples. It's the exact same thing, so we're able to group them together and write that as 2 sin x cos x. Now, if you wrote it as 2 cos x sin x instead, you'd be perfectly fine. The order doesn't matter as long as you're consistent. Now, sine squared x plus cos squared x, we know from the identity that that equals 1. So I can then take it even further and say that that equals 1 plus 2 sin x cos x. What I've done there is I've expanded the bracket and I've simplified it down as much as I can with the trig identities we know at this stage. When you're doing this sort of thing, you have to keep your eyes out for any of these sort of forms that come out. You have to use the identities properly and accurately, and you have to make sure that you are able to identify them at the click of a finger and know them off the top of your head.